camp this weekend. I'm sure Teacher Jen reminded you on Tuesday, but just a reminder again. Starting at 2:30, and hopefully, yeah, all in time for your exams. I know some people have started writing, you probably all have already started writing. So yeah, hopefully that gets us well prepared for exams. And obviously you're busy doing exam revision in the lesson. So a lot of revision, but that's good. You need to be doing a lot of revision because obviously you have a whole bunch of other subjects you're trying to prepare for, and at least this is 1 hour you're dedicating to it. Alrighty, so like I say, Teacher Jen has said to us, said to us that we are revising exponents and surds today. Do that. And so what that means is we're going to be revising all of the laws, all of the rules, all of the techniques that we need to use in order to simplify certain exponential and surd expressions, as well as deal with equations, etc., etc. Okay. So some of these you're going to do by yourself. Some of these I'll talk through with you, and then I'll ask you to do it by yourself. Oh, gosh. Some of them I will do with you. We're going to see where the wind takes us. We're just going to go with it. All right, so we should know our laws by now in terms of exponents. Surds is a little bit new, and so I'm just going to remind you about the surd law that you need to know, in that if you are given some root, let's call it the mth root of a to the power n, if we want to write this in exponential form, that is a to the power n over m. And I always think of it like a plant, the roots of a plant. Beautiful roots. That's a plant, apparently. The roots of a plant are at the bottom. So the root is always the denominator of your exponent. Okay, that doesn't look like a plant, but we're just going to pretend it does and move on. All right, so that's your surd rule that you need to know. And this is going to be a very useful rule, obviously, throughout the section, but also for you in terms of more complex problem-solving questions. So you're going to start to see when you start doing past papers in both grade 11 and grade 12. Often in paper 1, where the problem solving question comes in question 1, has to do with exponents and surds. And so if we can remember these rules, it means that when it comes to that complex problem solving question, we actually have all of the tools that we need to deal with it. And when we do approach those questions, it's not necessarily, oh, well, I need to know the answer straight away. It's what do you know? How can you use what you know in order to start solving the question? So the point of problem solving questions or complex questions is that there's no clear place to start, but you've been given the tools and the information to help you. And so this is what I'm saying. Know your exponent laws, know your rules, because those are the tools that are going to help you deal with those sort of complex questions. Right, so 1.1, we've got 16 over 81 is equal to, it's not equal to. Let's try that again. 16 over 81 to the power, I nearly said is equal to again, to the power negative 3 over 4. All right, so not only do we have a rational exponent, we also have a negative exponent. Now, grade 11s, there are so many different ways that you can answer, approach, deal with simplifying exponential expressions. It entirely depends on what you see first and what you want to deal with first, I suppose. Okay, so my advice to you is whenever you are in doubt, you start by writing down your prime bases. Okay, so if your numbers are not prime numbers that you're working with, that is the first thing that you're going to do. So for example, here, 16 and 81 are not prime numbers. You don't have to be able to do this in your head. You have a calculator that has a shift fact situation going on. So we would say 16 equals shift fact, and fact is on top of the comma things there. So you just say shift fact, and it will tell you what the prime factors are. So prime factors of 16, 2 to the power 4. Could do the same thing with 81, but prime factors are 81, 3 to the power 4. Now the reason I'm saying immediate, this pen is a bit thick, it's a bit hard to read, sorry. Let's just tone it down a little bit. So the reason I'm saying go immediately for your prime factors is because immediately I can see that they're both to the power 4. The next thing we hopefully remember is that if we have got 4 over 1 times something with a denominator of 4, I've just said 1 over 4, those 4's cancel, and we hopefully end up with a nice whole number. So working with prime bases often makes A, your working out easier, and B, the next step easier to see. Okay, so we've done our prime bases. This is still to the power -3 over 4. So that's my first step. Second thing, personally, I will always deal with a negative exponent first where possible. So because I don't particularly want to deal with a negative exponent, and you will never leave your answer with a negative exponent unless for some reason it said, sure, go ahead. We always want our answers with positive exponents. Now, the trick is when you are raising a fraction to a negative exponent, all you do is you flip the fraction. So 3 to the power 4 over 2 to the power 4 now. And this exponent becomes positive. Now, the reason for that is, let's just do something very easy, a half to the -1. If you distributed that in, you would have 1 to the power -half over 2 to the power -1/2. And to deal with those negative exponents, you would swap the two. So all I'm doing is doing the swap first before I do the distribution. So that's the trick when we have a negative exponent that we are raising to a fraction. Right, now we're going to apply our exponent laws. This tells me that I should distribute that exponent to all exponents in the fraction. Now I'm going to write this down like this. No, you would not need to write it down like this. So we're going to say 3 to the power 4 times 3/4 over 2 to the power 4 times 3/4. You don't have to write it like that. You can just do the multiplication. But what ends up happening is exactly what I explained earlier. Those 4's cancel. And so what we have is 3 to the power 3 over 2 to the power 3. And that's 27 over 8. Done. Okay. So again, this is not the only way to do it. There are many, many other ways to do it. But really, really importantly is for you to be able to work with prime bases and for you to be able to understand how to apply your exponent laws. So not the only way to do it, other ways to do it. Obviously, I think this is the easy way to do it because this is what I'm comfortable with. You need to decide what works for you. All right. Any questions? We all good? Obviously, if you do have questions at any point, please just let me know in the chat or raise your hand. Okay, I'm going to assume we're all good. If you aren't, obviously just shout. All right, 1.1.2. We have got, I'm just going to make it a smidge bigger. We have got 2 to the power n plus 1 minus 2 to the power n minus 1 over 3 times 2 to the power n plus 2. Does anyone have any suggestions of what I can do here? Because all these bases are prime bases. So that first step that I would usually always go to is out the window. What would I need to consider here? Okay, so I'm going to ask again, what do you think we should do here? What suggestions do you have of how to approach this? Okay, I'll go a step back. Can anyone tell me how many terms I have in the numerator? Awesome. Okay, so the second we have more than one term in either our numerator or our denominator, we need to think about factorization. Okay, so this is only when we have two or more terms. If it had been one term in the numerator, one term in the denominator, we can apply our exponent laws. So because I've got two terms in the numerator, I need to factorize. Now, when we do this again, lots of different ways that you can do this, and it depends how comfortable you are. My advice is take each of these terms and write them as the product of their factors. So what do I mean by that? 2 to the power n plus 1 can be broken up as 2 to the power n times 2 to the power 1, because we know that when we multiply those two factors together, they have the same base, so we would add the exponents n plus 1. So it means the same thing. I would do the same thing with the 2 to the power n minus 1, 2 to the power n times 2 to the power minus 1. That is all over. How many terms are there in the denominator? Good. Okay, there's only one in my denominator. So I'm just going to keep this as 3 to the power 2, but I am going to break up that 2 to the power n plus 2 as 2 to the power n times 2 to the power 2. Okay, so I haven't actually done anything yet. I'm just breaking my factors up. Okay, so let's go back to the numerator, because this is sort of the reason why we're doing all of this. What do you notice in those two terms? So look at those two terms. What do you notice? Nice, Leander. What is the common factor? Just two? So Leander said a common factor. Nice. Okay. So we have got a highest common factor here of 2 to the power n. And that's generally what's going to happen. You're going to end up finding that you have a highest common factor. And that's why I was saying earlier, we factorize. So we're going to take out that highest common factor of 2 to the power n. And this is also why it's really good to break up your factors, because often what happens is when we've got this 2 to the power n plus 1, when we take out a common factor, people often then just say there's one left. But we need to remember that that one is an exponent. It has to be attached to its base. Okay, so this is why if we've broken it up, we can clearly see we've got that 2 to the power 1 left in the first term minus 2 to the negative 1 in the second term. And that's all being divided by 3 times 2 to the power n times 2 to the power 2. And now because everything is either multiply or divide, we can start to divide. So the 2 to the power n's and the 2 to the power n's, they divide away. So what we have left is 2 minus, and 2 to the negative 1 is a half, over 3 times 2 squared, which is 3 times 4, which is 12. Now, honestly, grade 11s, at this point, I would just put that into my calculator. It's entirely up to you. It usually says without a calculator, but put it into calculator. If you are a stickler for the rules, without a calculator, what we would do is we would say 2 minus a half is 1.5. And then because I've got fractions that I'm dividing with, I'm now going to write the division sign by 12. I'm then going to tip and times, so 1 over 12. And because, again, I can simplify, 3 divides into 3 once and into 12 4 times, I end up with 1 over 8. Right, like I say, personally, once you have dealt with the negative exponent and multiplied what you can, I would just type this into my calculator. But like I say, if you are a stickler for the rules, just go back to how you work with fractions. So really importantly here, grade 11s, when we have two or more terms, and it can either be in your numerator, your denominator, or even both of them, what we need to do is factorize. 9 times out of 10, it's going to be a highest common factor. If we wanted to sort of increase the complexity, we could have like a difference of squares or a trinomial, something like that. But at this level, it is usually a highest common factor. Like I say, not always, but usually. Right, so I'm just going to make those two smaller so that you can screenshot those two. You can see your mark allocation there. Would anyone like me to show them what the mark allocation would be? Okay, so there was a yes. So for the first one, again, it's going to depend on the method, and obviously we adjust our marking according to your method. We don't only mark one method correct. But essentially, the gist is going to be prime bases, dealing with that negative exponent, whoops, and distributing in the exponent, which is often just written as simplify on the memo. So those are the 3 marks for that first question. For the next question, this is 4 marks. So you're going to often get a mark for your highest common factor. Okay. We often then give a mark for the remaining factor. So that's 2 minus a half. You're going to get a mark for simplifying that negative exponent and a mark for your answer. So even in the first one, the simplified distribution mark could also just be straight away the answer mark. Okay, so we could just kind of go straight to the answer and not necessarily have to do too much else. All right, so those are your mark allocations. Again, if you have done it slightly differently, we will adjust our marks accordingly. So let's say, for example, in the first one, you didn't deal with the prime bases and you just kept it as 16 and 81. Ooh, excuse me, and you dealt with it like that and you sort of raise them to different powers, whatever. It's fine. As long as it's mathematically correct, we adjust the mark allocation according to your method. All right, so I'll wait in case you want to screenshot it with those mark allocations, and then we'll have a look at the next one. And remember, guys, if you do have questions as I'm going along, please just ask. Okay, so let's have a look at 1.3. We have got a lot. So just make it a little bit bigger so we can actually see what's happening. 6 times, okay, there we go. 6 times 2 to the power n minus 1 times 8 to the power n plus 1 divided by 9 to the power 1 minus 3, 1 minus n, sorry, times 3 to the power 2n times 16 to the power n. Okay, that's a lot. So first question, how many terms do you have in your numerator? How many terms do we have in our numerator? Okay, good. Right, yes, we've got 1 term. How many terms do we have in our denominator? Good. Okay, so we only have 1 term numerator, 1 term denominator. So that means I'm not going to factorize. I'm now going to apply my exponent laws. Now, my next question to you is, how many different bases do I currently have there? So how many different bases do I currently have in this question? Count how many bases you have, how many of them are different to each other. Okay, so if we have a look, we have got a base of 6, a base of 2, a base of 8, a base of 9, a base of 3, a base of 16. That is 6 different bases. Okay, I do not want to be working with so many different bases because remember, your exponent laws, particularly when you multiply and divide, only work if you have the same bases. And because this is a fraction, obviously I'm dividing at something. So this is where your prime basis becomes really, really important. Prime basis generally means that we can go down from 6 bases to maybe 2 or 3, and it allows me to simplify. So let's start with the first one, 6. How do you write 6 as a product of its prime factors? So what prime numbers do we multiply to get 6? What prime numbers do we multiply to get 6? And again, you can use your calculator if you want. Nice. Okay, 2 times 3. Those are 2 prime numbers. 2 times 3 is 6. 2 is a base. It is a base, yes. 2 is a prime base. So that 2 to the power n minus 1, that can stay. Not unhappy about it. Right, 8. How do I write that as a product of prime bases? Good. 2 cubed. But what we must remember is that it's been raised to the power n plus 2. We'll deal with that in a second. Right, 9. How do I write 9 as a prime base? Good. Okay, 3 squared. And again, we must remember that it is being raised to the power 1 minus n. 3 is a prime base, no problem there. 2 to the power n. What about 16? How do I write 16 as a prime base? We actually did it again, 1.1. Good. 2 to the power 4. So 2 to the power 4, but still being raised to the power n. Now, grade 11s, what I want to impress upon you at this point is, do you notice how even though I could have distributed in the same step, I am not? Okay. When it comes to exponents, it is just application of rules, but don't try and rush it. Okay, so rather take up half a page with your working out than try and rush through everything and then make really silly mistakes. Because what's going to happen here is all we're going to actually end up doing is distributing, so multiplying, and then adding and subtracting like terms. That is quite literally all we have to do now. But when we rush, we make really silly mistakes with either the distribution or the addition and subtraction, and we don't want to do that. So rather take a little bit longer to get to the correct answer. All right, so my next step is going to be exactly that. I'm going to distribute. Everything that doesn't need to be distributed, I'm going to leave it exactly as it is. That last factor, my numerator, we're going to distribute the 3 to the n and the 2. Again, a very common mistake that is made. We don't distribute to both. 3 times n and 3 times 2. So this is 3 to the, it's not, it's 2 to the power 3n plus 6. Okay, don't forget to distribute to every term. All over 3 to the power 2. Again, we're distributing minus 2n times 3 to the power 2n times 2 to the power 4n. Okay, so all I've done is distribute it. Next thing I'm going to do is I'm going to simplify. Again, you could do everything in one step. I am not going to. I'm going to deal with my numerator first, and then I will deal with my denominator. Okay, it will also be in one step, but I'm going to deal with it slowly. So in my numerator, I'm going to look out for my common bases. So 2, 2, whoops, 2. Those all have the same base. And because in my numerator I'm multiplying, I'm going to add all of those exponents together. This first 2 has an exponent of 1. And so what we have here is 2 to the power 1 plus the n minus 1 of the second 2 factor plus the 3n plus 6. And I still have that times 3 there. Okay, so that's my numerator sorted. Then I'm going to move to my denominator. I'm going to do exactly the same thing. I'm going to simplify. And I'm going to identify what bases I'm working with. Right, so I have got 3 to the power 2n minus 2, 3 to the power 2n, and then I have that 2 to the power 4n. So when simplifying this, I've got 3 to the power, and again, in my denominator, I'm multiplying. So 3 to the power 2 minus 2n plus 2n, and then I still have that times 2 to the power 4n. Again, yes, you absolutely could do all of the multiplication and division at once, but I'm not going to because I don't want to make a silly mistake. So I'm going to simplify this. 1 minus 1 cancels out. N plus 3n is 4n, so we've got 2 to the power 4n, and then we still have that plus 6 at the end, times 3. In my denominator, I've got 3 to the power minus 2n plus 2n cancels, so I've just got 3 to the power 2 times 2 to the power 4n. Now I'm going to deal with the division. Can anyone tell me what I do with the exponents when I divide? Okay, good. We subtract. So remember, we must work with the same bases. So I've got 2 to the power 4n plus 6. And I'm going to subtract because I'm dividing by 2 to the power 4n. So I subtract that exponent of 4n. We keep it as times between my bases. We've got 3 in the numerator, which is 3 to the power 1. And then we subtract the exponent's numerator, the exponent's, that was too many words. Let me try that again. We subtract the denominator's exponent of 2. Sure. Right. 4n minus 4n cancels out. So I'm just left with 2 to the power 6 times 1 minus 2 is 3 to the negative 1. Once again, grade 11s, you never want to leave your answer with a negative exponent. So we will write this as a fraction. 2 to the power 6 is 64 over 3. If you left it as 2 to the power 6 over 3, personally, I would have no issues with that. I would give that 100%. Okay. Some people seem to take issue with that. It's just another way of writing 64. So I wouldn't care. Obviously, do what your teacher has told you to do, but it's the same thing. Okay, so I took longer to do this. Absolutely. But I didn't make any silly mistakes, and I made sure that I was going step by step, slowly, so that I didn't make those silly mistakes. Right, when it comes to your mark allocation, mark for prime bases. Sometimes they might give you a mark for prime bases in your numerator and in your denominator. I'm going to see how the mark allocation works now. We'll see how it goes. We then get a mark for simplifying. So applying your exponent laws, multiplication and division. That's not how you spell simplify. Hey, simplify. You'll get a mark for dealing with that negative exponent. And then a mark for your answer. Sometimes that dealing with the negative exponent, they might allocate your marks as 64 in the numerator of your answer and 3 in the denominator of your answer. Again, it just depends on, how it's marked, who's setting the memo, etc., etc. Especially at a grade 11 level, sometimes we do split it up like that. So that's generally your 4 marks. And this is why I go back to, when in doubt, prime bases. 9 times out of 10, that's a mark. So if that's the only thing you can do, at least you're getting 1 mark. Usually, once you have your prime bases, you can kind of see, okay, cool, well, now I've got a lot of common bases. Let's apply the rules. And it helps you, like I said, lead you into the next step. Right, I'm just going to wait for you to screenshot. And again, obviously, if you've got, if you've got questions, please let me know. Right. Give me a thumbs up if you think you are ready to give one a try by yourself. So we've kind of gone through most of what you need to know. Are we ready to try one by ourselves? Give me a thumbs up. Okay, right, here's your one. Notice that you've got two terms in your numerator and two terms in your denominator. And we said two or more terms means you must factorize. So that's your hint. This is worth 4 marks. I'm going to give you 4 minutes. Let's give it a try. You can put your answers in the chat, or if you've got questions, you can ask as well, obviously. Alrighty, let's have a look. Okay, so first things first is we're going to separate our factors. So we've got 5 to the power x times 5 squared minus, you can write that as 2 squared if you want, but you're welcome to just leave it as 4 as well, times 5 to the power x. And then in your denominator, we're going to separate 5 to the power x times 5 to the power negative 1 plus 2 times 5 to the power x times 5 to the power 1. Okay, so what we now notice is that in my numerator, I've got a common factor of 5 to the power x, and I have the same common factor in my denominator. And this hopefully will happen to allow us to obviously divide those away. So we take it out, 5 to the power x, leaving me with 5 squared minus 4 over highest common factor, 5 to the power x, 5 to the negative 1 plus 2 times 5. So those 5 to the power x's divide away. So it's gone, and all we have are the numbers left. 5 squared is 25, minus 4 is 21, over a fifth plus 2 times 5 is 10. Again, guys, I would just type that into my calculator. Okay, we're not testing whether or not you know how to handle fractions. We're testing, do you know how to factorize? Do you know that 5 to the negative 1 is a fraction of a fifth? Okay, that's it. Obviously, if you feel strongly about it, 21 divided by a fifth plus 10. Obviously, we would find an LCD there, so that would be 5. So 50 over 5, which would be 51 over 5. Tip and times all of that fun stuff, you end up with 35 over 17 as your final answer. Right, again, this was a 4 marker. So here, factorizing your numerator, factorizing your denominator, simplifying, so that's where that dealing with that negative exponent situation comes in, and then a mark for your answer. Right, so as you can see, exponent questions are hefty marks, like 4 marks in a 50-mark test, that's 8%. You get 2 or 3 of those, you sorted. Okay. We're under, sorry, 10,2, I don't know what that means. Oh, I do know what that means. Sorry. No, I don't know what that means. Where's 10,2 coming from? 51 over 5. Yes, sorry. If you want to write it as 10,2, that's fine. Personally, I never work in decimals, but sure. Just remember to still say 21 divided. No, thank you for helping me because I didn't actually know where that decimal was coming from. So thank you. It's clearly, I just blocked decimals out of my brain. I don't like decimals at all. So yeah, thank you. And yes, guys, you are more than welcome to write it as a decimal. Like I said, I don't, and it's not the norm, but we're not going to mark you down for using a decimal. So by all means, if you're more comfortable with that, go for it. Right, I'm just going to wait there for you to screenshot. Okay. So let's give 1.5 a try. We've got 25 over 49 to the power negative a half. So basically almost exactly the same as the first question, just different numbers, times root 5 squared. Now just think logically about inverse operations there. But again, I'm going to give you 4 minutes. Let's give this one a try. Remember, if you've got any questions, feel free to ask, or you're welcome to put answers in the chat. Okay, nice. If you got 7, well done. Let's have a look at why it's 7. So again, prime bases, 25, 5 squared, 49, 7 squared. Hopefully we're noticing that because of the half, when we eventually distribute in, the 2's are going to cancel. Okay, now inverse operations, the inverse of square rooting something is to square. So those actually just cancel each other out. So we just have times 5. Okay? That negative exponent I'm immediately going to deal with by swapping my numerator and denominator and just raising it now to the power, positive a half. And like I say, what's going to end up happening when we do distribute that is that the 2's will cancel with the half. And so all we're actually left with is 7 over 5 times 5. When we multiply, again, 5's divide away. And so all we're left with is 7. In terms of your marks, so a mark for the 5, so understanding that inverse operations just cancel. Mark for your prime bases, a mark for dealing with that negative exponent, and a mark for your answer. Okay, so again, nice easy marks. Go step by step. If you need to draw out your working out, do that. But exponents should not be something we're losing marks in. Right, again, just take your screenshots, and then we'll have a look at the next one. Okay, guys, it does become easier with practice. Okay. Alrighty. I'm going to ask you to try this one, question 4. What I'm going to say is, remember BODMAS. So BODMAS tells us that whatever's underneath the root, we treat like what is inside a bracket. So don't worry about the root right now. All I want you to do is deal with the fraction. So if you need to ignore the root, fine. Deal with what's happening underneath the root. And then once you've simplified everything, you can come back to the root. Leander, I can't answer that. I'm sure Teacher Jen has got it in her plan. I can ask her, but because, like I say, she is busy, she's not going to get back to me in time. But I have full faith that she will be doing it, but I will mention to her that you would like to revise functions, just so that it is on her radar as well. Okay. All right, guys, let's give this a try. Again, deal with what's underneath the square root first, and then we will deal with the square root. But again, 4 marks, 4 minutes, let's try. Right, nice. So yes, indeed, 4 is the answer, but let's have a look and see. Right, and guys, I am giving you the 4 minutes that I say, and that's just sort of a good way to manage your time. So a mark a minute, pretty decent sort of way to gauge how much time you should be spending on something. Right, so we're going to split it up. Again, if you don't need to, you don't have to. It's just sometimes easier to see what needs to be factorized out and what factors are then remaining once you have taken out that highest common factor. That was weird. Okay, whatever. Over 2 to the power x times 2 to the negative 2. Alrighty, so we can clearly see that in our numerator, we have got 2 to the power x as our common factor, leaving us with 2 cubed minus 2 squared all over 2 to the power x times 2 to the negative 2. Right, 2 to the power x divided by 2 to the power x. It's just 1, so those simplify away. And we are left with 2 cubed, which is 8, minus 4 over essentially a quarter. All right, so 8 minus 4 is 4, and we've got 4 divided by a quarter, which ends up being, I'm going to carry on here, when we tip in time, sorry, I panicked there, 4 times 4, square root 16, which gives us positive 4. Alrighty, so this would be considered a more complex question if it was given to you in a test or an exam, just because of that square root. That's really it. But it doesn't change anything. We're going to factorize. Factorize. We are going to simplify. Okay. We're going to probably get a mark for that 16 and then a mark for our answer. If you didn't get a mark for the 16, you might have gotten another mark over here for the remaining factor after you factorize out the 2 to the power x. Again, depends on the teacher, depends on, yeah, but that is where we would get those 4 marks. I'm just going to wait in case you want a screenshot. And then one more, you're going to give it a try, and then we will see. Okay. Right, so question 1.7. Whoops. Question 1.7. We've got this beauty over here. Only one term in numerator and denominator, so what you now need to think about are your prime bases. Right, so let's give this a try, and then we will have a look. 4 minutes, and then we'll have a look. No, this one is worth 4. Sorry, did I say 2? My bad. Apologies. 4 marks. Alrighty, grade 11s, just for the sake of time, I will zoom back in now. This is your answer to this question. I'll put it nicely here. Okay. Okay. Right, so this is the answer to this question. Let's just go through it. So obviously, once again, what we want to do is we want to deal with our, sorry if you can hear my cat, prime bases. So that's what's happening here, prime bases. And because in your denominator, 9 needs to be written as 3 squared, and you then have the exponent and the root and all of that, start with the 3 squared and the distribution, and then you can deal with the square root. Now remember, when you square root something, you divide. So we would have 3 to the power 2a divided by 2 for the square root, plus 2 divided by 2 again for the square root. So that's where that a plus 1 is coming from. We simplify that. We add and subtract the exponents for the like bases. So 3's, that's all happening there. And just that we are aware, when we subtract this a minus 1, it becomes minus a minus 1. And then we have for the 2's over here, and we simplify to get 9 over 4. So like I said, there's 4 marks, prime bases, dealing with the square root, simplifying, i.e. applying your exponent laws of multiplication and division, and then a mark for your answer. All right, so once again, step by step, go slowly, don't rush anything. If you need more space, I don't want to say more time, but more space in particular, rather take up more of the paper, rather draw out your steps so that you aren't making any silly mistakes. Alrighty, so I'm just going to wait there for you to screenshot. It is 6:30, so if anyone obviously has last minute questions, that's fine. But otherwise, good luck with your exams. If you're writing, enjoy the rest of your evening. If you need to go, that's fine. But I'm going to answer this question. So why did the 2 to the power 2a, okay, hang on. You're so right. Okay, see. Oh, teacher Jane. No, I'm joking. Right, hang on. Let's just I want to get rid of all of this. Okay, so let's just do this properly. Okay. See, this is exactly my point. Sometimes we just make silly mistakes. So this will be 3 to the power 2a plus 2 times 2 to the power 2a minus 4 over 3 to the power a minus 1 times 2 to the power 2a minus 2 times, and hopefully we can all agree, 3a plus 1 when we deal with that square root, because it would be square root 3 to the power 2a plus 2, and then we apply the square root, we get that. Okay, so we have that. Let's just leave the numerator for now and just simplify the denominator. So I'm going to add just those base 3's. So 3a plus a is 2a minus 1 plus 1 gone. Then we've got 2 to the power 2a minus 2. And like you say, it must stay 2 to the power 2a minus 2. Then I'm going to subtract. So 3 to the power 2a plus 2 in the numerator minus 2a in the denominator times 2 to the power 2a minus 4 in the numerator minus 2a minus 2. So then we distribute that in. 2a minus 2a, so we just left with 3 squared, plus, if we distribute this, 2 to the power 2a minus 4 minus 2a plus 2. So 2a minus 2a gone, minus 4 plus 2 becomes 2 to the negative 2. Okay, so the answer was right. We just had typed it wrong. So 9 over 4 is still the answer. But yes, I agree. That's 2 to the power 2a shouldn't have changed. Thank you, Leander, for picking that up. Okay, so if anyone wants to screenshot that, all that had happened was that that had changed, but no, it shouldn't have changed. The answer's still right, but yes, there's the correct method. Thank you so much. Alrighty, grade 11s, but like I say, good luck for those of you writing exams. Like I say, I think almost everyone has probably started now, if not this week, probably Monday. So good luck with the studying. Good luck. Yeah, just getting ready, getting prepared. Make sure you're taking breaks. Don't overwork yourself. And then don't forget about boot camps on Saturday if you have signed up for them, where Teacher Jen will then see you. Right, I have mentioned about the functions revision, so just keep an eye out for that. But have an awesome rest of your evening, awesome rest of your week, awesome weekend, all of those fun things.